Hi, welcome to part 3 of our overview on ORE Studio. As I mentioned in the previous video, we're probably just going to have a few of these until we sort of establish the lay of the land, and then possibly have more dedicated videos that are a bit more specific to topics, because these videos are becoming a bit too long and long-winded, but I still think they're useful, I think. So in the previous video, a couple of things before we get into other details. So in the previous video we spoke a little bit about AAD, and one thing I think I didn't do very well was I didn't really explain what it is that it is about. I think one of the objectives of ORE Studio is to allow developers, regular programmers that have an interest in C++, but want to move into the world of exotics and quantitative finance, to be able to map the domain, to understand how it works. Because as anyone who's joined finance, you probably find that it's a bit like going to a foreign country, really. I remember 20 some years ago when I joined the city, it was quite difficult to even follow conversations because they speak a completely different language. I mean, it's a bit overwhelming actually in the beginning, because it's maybe out of 10 words, maybe about 8 words are some kind of domain keyword, and you don't even notice when you're in the domain for so long. You start to think that this is how people talk. Everyone's talking about vol surfaces and expiries and long, short, and all sorts of things. And for somebody that just comes from, even if you have a very strong programming background, it takes you quite a while to find the lay of the land until you can start to really understand what people mean. I don't think finance is particularly complicated, especially after spending a little bit of time at uni, especially with computational neuroscience guys. I think that it's probably similar to other fields in terms of complexity. It's just that because it's not so easy to learn the basics of it, and because in many cases you need to actually be inside of a hedge fund or an investment bank to have access to the technology that they're using. It's difficult for you to just pick it up at home. I mean, things have changed over 20 something years. So now, of course, you can download Quantlib, you can download ORE, the open source risk engine. And there's other many open source projects which we will hopefully make use of. There's some that do something similar to what we're trying to do with ORE Studio. For example, OpenGamma. I was fortunate enough to have met some people from the OpenGamma community and company when it was quite young, all those years ago. And it is open source. I'm not sure if things have changed since then, but not so long ago it was a completely open source solution written in Java. And it did enable you to learn a lot about the field of computational finance, as I like to call it, quantitative finance. However, the problem with OpenGamma, in that sense, OpenGamma is very similar to the sort of systems you're going to face in a hedge fund or in an investment bank. These systems are very, very large, and they're very complicated, and they require a lot of data to drive it in order for you to even be able to just run some basic stuff. And so maybe if you know what you're doing, it's maybe quite good that you use something like OpenGamma or other similar packages. But if you're trying to find your way, it's a little bit hard. So one of the objectives I had with ORE Studio was to try to simplify things as much as possible, and to try to make it accessible to somebody. Ideally, what I really want is for somebody to just download a few binaries, start some services, and connect with the UI, and be able to do end-to-end work. But I also want to introduce the domain as we start introducing the application. One of the things we would like to do when MCP integration is done is the ability for you to just talk to the AI and ask the domain questions. That's not going to be actually that hard to do, because there's already good local models that are probably good enough for that sort of thing. For example, Quen 3.6 is quite good. I've been playing with that. Even the 8-billion variant is quite good. So I think it's something that we could probably integrate quickly. I haven't got time to do it now, but I think it's something that's probably a sprint or a sprint and a half worth of work. But it would provide somebody to talk to when you want to ask questions about the domain. We'd have to prompt the model properly and perhaps fine-tune it a bit, but I think it's doable. But anyway, what I'd like to do is when I introduce a concept in these videos, I'm going to try to give you a bit of background. Not completely explain to you how things work, because that's one of the problems of finance, is that in order to explain anything, you need to explain everything. So if I just want to explain something as simple as, say, I don't know, a delta or a gamma or something, we end up probably spending a lot of time deep in the weeds to try to just explain something as simple as that, because nothing is simple. So anyway, in the previous video, we mentioned AAD, and I think that was a good point at which I should have spoke a little bit about the domain instead of just a hand wave a definition. So in this video, we will just start by quickly addressing that gap. Now, I'm not actually, because obviously the AAD conversation just came about because of that exchange I had with the Mathologica guys, not something that I was actually directly working on. I'm not going to spend huge amounts of time on this, but once we start touching the AAD stuff, probably we'll re-enter this topic again. For now, I just wanted to close that bracket that we opened in the last part. So, as I mentioned before, AAD is basically a technique that enables you to compute sensitivity. So what I've done is I just did a quick Google search, and I'm using Gemini here as our way of explaining the domain concept. So, as I said, one word that you're going to hear a lot is sensitivities, or Greeks. Greeks more likely if you're in trading floor, sensitivities more likely if you're working with the quants. So the idea is that for every mathematical model that you got that is able to compute the value or the price of an instrument at a certain point in time, it also is able to calculate or can calculate sensitivities of that instrument in terms of the input variables to that to the model. Common input variables are, for example, the interest rates, a vol surface, time, and so on, right? And you can think of this, the technical definition of this is basically the first and the second derivatives of the function with regards to one of the inputs. Now, AAD is basically a way of computing those sensitivities in a faster way. So when we compute sensitivities, and this is the problem, as I said before, you end up actually having to explain a lot to explain something simple. So when you compute sensitivities, there's roughly two ways of doing it. There's the analytic way, or the closed form way, and there's the sort of the numeric way. When we're computing things numerically, we tend to just bump, which is what we talk about here. We tend to just bump the input by a certain amount. We calculate the NPV prior to bumping, calculate the NPV after bumping, and the difference between the two is the sensitivity. So in other words, as an intuition, what we're trying to say is take the world as it is, change only one thing, calculate the new value. The difference between the new value and the old value is basically completely attributed to the change that you just made. So that being the case, what you can think of when you're talking about AAD is basically a way to use the process of differentiation. Instead of just using it to calculate the value, it uses the process of differentiation to build a structure. I'm just using the term very generically here, the structure that captures the computation that you're making. And then with that structure then, and herein lies the magic of AAD, with that structure then, you're able to then revalue, in other words, redo the computation you just did, but a much, much, much faster way. So one good way of getting intuition to calculus, and you'll see how this links up in a minute, in particular, just bear in mind forward pass and backwards pass that we got here. One very good way to build an intuition for what calculus is doing when we're trying to differentiate a function is to play around with Karpathian, the Karpathian stuff. Now, Karpathian is a personal hero of mine. Excuse me. I'm afraid my voice is going. So Karpathian is a personal hero of mine, and Ori Studio, in a way, is inspired by the many, many, many videos that Karpathian has created and that I keep finding and following. He tends to create lots and lots of didactic and teachable material that it makes. It's a great way to build an intuition on almost all the concepts around LLMs and generative AI. And what he does is he tends to create these little toy, I'm using air quotes here, toy programs that are small enough that you can still look at the code and understand what the code's doing, particularly if you come from a proper development background where you don't know the domain of AI, but you know programming quite well. So when you see it in code, most programmers tend to reason like code. We understand code really well, and for us, code is almost like the simplest possible way of learning something, because we can modify the code, we can understand what the code's doing very quickly, and so on. And the kind of approach that Karpathian has is, I think, a great approach to learn things and to build intuition for things. So some time ago, I don't know, maybe about a year ago or something, I was doing Karpathian's courses on how to build an LLM, and one of the lessons I did was the Micrograd lesson. And the interesting thing about Micrograd is sort of an example program that explains how backpropagation works. And what it does is it takes any expression and it shows how the differential equations or the derivatives of the equation are computed in a numeric way. I think it's a great way for you to build an intuition for what calculus is doing behind the scenes. Because I think when you look at calculus from instead of looking at calculus from a continuous perspective, which is how they teach you in maths, which I found, I'm not very good at maths to be honest, but I found that discrete maths for me works at a different level than continuous maths. I can understand very easily, very quickly discrete maths, because at the end of the day it breaks down to very simple arithmetic problems or things that look like programs. So I think pretty much any computer scientist, any programmer really, any developer can understand something that's explained in terms of discrete maths. But once you start to get to the higher levels of abstraction of maths, particularly things that are continuous, it's not so easy to get an intuition. So what I tend to do is I tend to always try to gain my intuition via the discrete way. And once that's done, then I try to imagine what would happen if you move into continuous domain. And that tends to be a very good way to build an intuition. Now, of course, if you're a mathematician, you probably say that's probably not ideal. But I think most computer programmers eventually have to map the continuous world to the discrete world anyway, because you need that for implementation. And it's probably sufficient for you to get a really good intuition. And so, linking back to Micrograd, if you want to understand how you can hook in to the differentiation process and use it to intercept and overload the forward pass and the backwards pass of any symbolic expressions, Micrograd is very, very good at that. It will really, really build that intuition. And I look at the video. I think this is the video I watched. You can see that Karpathian goes very slowly through the whole process, and it would not be horrendously complicated to take the Micrograd code and instead of using to do what Karpathian has done, for example, he used that overloading that I was describing to build this graph here of the expression. It wouldn't be overly complicated to do that, to simulate what AAD is doing. Instead of doing this, you'd be doing what we described here in this AI explanation. I won't spend time doing that right now because, of course, we have many other things on the go, and it will be very time-consuming. Well, probably no huge amounts of time, but it will take some time to do that. And even I've never implemented AD before in my life, so even I would probably take some time to be able to understand it properly. But it would be a very good way of building intuition for what AED is doing. For now, all I'm going to say is what the process of AED is doing is very, very similar to what you need to do with a tool like Micrograd. And the idea is that you're intercepting the process of differentiation, not just to do the actual differentiation, but to do something else, which in the particular case of AED is to record a tape with the instructions of the code that you're running, and then you use that to create a function that is able to compute in the absence of the rest of the code. So hopefully that's going to be sufficient for now, so you have an idea what's going on here. So we've introduced a few terms there. Terms that are going to be very, very important, so hopefully you will remember these now going forwards. And if not, I think in other videos, once we start getting to pricing and so on, we can revisit this topic. Okay, so I must not forget to put this in the description notes of the video. I will close these tabs just to allow us to move on. Another topic as well, because it's not completely related to the topic of this video, but worthwhile mentioning. As you can see here, the bills are going through. They look alright. Seems like the fix that we introduced previous video worked. However, it seems like we are still failing on OS X, but I suspect this is probably, in fact I think we've looked at this before, it's just probably some kind of GitHub problem. Unfortunately we have this a lot, a little bit unstable GitHub overlay. So that's good. So continuing on to what we're going to do in this video. So we left our little environment here with our counterparties. I've already, in the previous videos, I've already spoke a little bit about a lot of the ref data that we got here. As I say, I'm not entirely sure why. I think the main reason why I definitely need to look at slowness in the system at the moment. So I'm not entirely sure why it is that we are so slow at loading some reference data. I suspect this is something to do with the way that we're caching images, because the slowest dialogues seem to be those that use currencies quite a lot. We do use paging as well. I don't know if you noticed that before, but we use paging just to stop us from loading too much data in one go. So as you can see here, a page size is about 100. So and also interestingly, when we click on countries, that seems to be pretty quick. So if I just close currencies and reopen it again, yeah, this is definitely something to do with image caching. Not sure exactly why, but seems to be the case. So we've already spoke a little bit about all of these bits of ref data. What we really wanted to do, which we failed in the past, was to run the ORE import. Now I'm not sure this is going to work. Reason why is because, like I said, we just moved to a workflow based implementation of the workflow. Sorry, of the import, and I'm pretty sure I did test this, but I may have broken something on the process of updating the workflow. So anyway, what we'll do is we will I'm just going to look here at the examples. I think I've created a subset. So ORE has got a really nice set of examples. I think I mentioned this in one of the parts. Really nice set of examples that exercise the entirety or the majority of functionality in ORE. We've made a local copy here under external. Contains all the XML needed, and you can use that to value. So what we will do is we will locate the product. I should have not clicked on that. And then in products here you can see there's these example traits. This contains all of the example traits. Now I don't think we are, okay, well, I think we are in the process of just testing the supportive traits. I think that was the last thing we were doing before the last sprint ended. So what we'll do is we will just import one of these products, which is FX forwards. And then in here we will select the book, choose a counterparty. Now that we have counterparties, this is now working, so any random counterparty will do. Leave the date as default. Now, as you can see here, we submitted a workflow. It doesn't actually directly import, because of course we could have hundreds of files that we're importing. And you got this workflow ID here, which hopefully enables us to go to the workflow. And according to this, I'm not sure if I trust this, but it's telling us the workflow completed successfully. No errors, okay, that's good. So if I refresh this, okay, that's correct, actually, it did complete successfully. Again, we seem to be refreshing rather slowly at present. So as you can see here, like I'm clicking on the book with the trade, and it's taking quite a while. So before we move on in this sprint, I think the very first thing we need to look at is to understand why the UI is performing so slowly. We do have a lot of logging, so it should hopefully make our life easier. As you can see, it's taking a very, very long time. So I'm just gonna, and because of that I keep clicking away from the trade. So as you can see here, we've imported the FX forwards. Now, if I recall correctly, so this is what I was working on. As you can see, it said that everything was imported correctly, but in reality it lied. And it did import the trade envelope properties correctly, but the instrument properties don't look terribly good. So they all look blank. So there is a bug on the imports workflow, which is what I was working on before I finished the sprint. But nonetheless, this should give you an idea of how the imports ORE functionality works. What we should have had here is we should have had an error in the workflow saying that there was some kind of failure in the import process. And that's more or less where we left it, because as I said, we were migrating everything to the new workflow approach. So we've created a set of tests that are supposed to round trip the instruments, and we're kind of validating instruments one at a time. The very first one being FX forward, and it's why this that's the only supported product you see there. We do have a lot of code for all the other 150 products, but we have not tested that yet. I do believe we also started work on importing other kinds of things. So what I'm going to do now is I'm going to do something slightly different. I'm going to say go to Academy, and here you see the IR swap that we had not so long ago when we imported as a package. So we'll take this directory, and this has more than just trades. So let's just see what this does. As I say, we are sort of experimenting as we go along, because I have not completed. Okay, this is good. You can see the workflow is in progress, and now it's completed. Again, I think the reporting of the workflows may not necessarily be the best. So now if I go here, as you can see, there's the eventing. We still have that bug that we have not addressed, which is our eventing is not working correctly. We should have had an event here. But nonetheless, let's just open this up. As you can see, we have a new trade. Into the same book. So again, take a few seconds to do the right thing. You can see the swap is here. Again, I suspect our instruments is not going to look great because of the bug we have in mapping. That's fine. But you can see the booking here. Your booking in all the properties. Now, what I'll do is I'm going to quickly see, yes, and as expected, market data is not going very far. Okay, so I think the problem here is that we have not hooked up the importing of market data. All the functionality exists, but it's not actually hooked up. So the focus on this sprint then is going to be to finish the issues that we had with the ORE workflow, improve on the error reporting, also improve on the instrument processing, and hook up the new elements that we are importing. As you can see there, we seem to be importing some things, but we're not processing them correctly. So I think that's probably it for this video. Oh, and also another thing, sorry, one more thing. Let's have a quick look how long we've been in this video actually. So 23 minutes, okay, this is going to be a short one. So what we did, or one thing we didn't do so far is, I described how compute works in bits, but I didn't really explain how it all hangs together. So in the previous video, we manually submitted something to the grid, which is another way of saying we went to the dashboard. Went to the console, I mean, and in the console we created a work unit, and we selected the batch, and we selected the app version, and so on. Now, as I was doing that, I noticed number one, a number of problems, and number two, I forgot to explain how this works in the real world, because mainly the reason why this exists is so you can test the grid in chunks. I mean, this will be available in the final version. You would always be able to run things by hand if you wish, but that's not how most things will work in the system. the way things will work in the system is you would go to reporting, and you would create a report. Now, of course, remember that we're here as admin with the root account. This is the root party and the root tenant. And so there are no reports as such associated with the root tenant, because the root tenant is just a container for data and so on. What we want is a real party. So for example, in this case, we're in Partners PLC, which, as I said before, is the sort of the head of the group. In fact, one thing I would like to show you, which may help to clarify what I'm trying to say. I have showed you before a view of parties, which is this flat view here. And so it's kind of hard to tell how these entities are organized. But what we can do is, if you find one of these entities, in particularly the root, you can look at the hierarchy. And this tells you, according to Glaive data, the relationships between entities, as in parents. So you can see here that PLC is the root of the group, and then it owns many entities such as Barclays Bank PLC, Barclays Bank UK PLC, and so on. And then in there, there's another number of entities as well. So this is a good way of visualizing the hierarchy of parties. Okay, so now I got slightly sidetracked. What was I trying to say? Oh yes, I was talking about reports. So if I go back to reporting, as I said before, parties have associated with it a series of report definitions, and those definitions have a schedule. Schedule is just basically a cron expression. We don't use cron. I did mention before cron quite a lot, and we gave the impression that you need to have cron installed. It's actually, we use a library internally and the schedule service that just schedule things. So anyway, each of these reports, or these report definitions, has associated with it a definition, which is another way of saying a description of the report, and then soon enough, not yet, but soon enough, you'll have all of the configuration that goes along with that report. I don't want to get too lost here, but suffices to say that in order for you to run a report, you need a lot of configuration. I'm not sure how much I want to start talking about that now, because it could get us into a bit of complicated territory. But just imagine that there's a number of inputs, and those inputs are just the things that we saw already in. So if I just go back to Emacs, you remember in the examples we had. I'm just going to go to Academy, I think, which are the simplest examples. So in the examples, you've got all this input data. Now, this input data, part of it is just RAF data. So for example, conventions and so on, which is another way of saying, if you go to RAF data and you open up some of these entries here, you're going to find some of this data. Now, I don't actually think by conventions we mean this. We actually mean, if I just open up that conventions file, terminology that we use in ORE is slightly different from, okay, right. So by conventions here, what we mean is we are mapping those instances of conventions to each specific instruments. For example, this case is mapping this to this, and then whether it's index based or not. So not entirely sure how much we've implemented of this, because I was doing this in parallel with other things, and I'm not entirely sure where things are in the menus, because, as I say, we just revamped the menus, which is a bit confusing. I mean, it's better than what it was, because before we used to have less menus and very big jumble of things. With the latest reorg of the menus, we tried to make things slightly more sensible, but I need to get used to the new organization of the menus. So I think the conventions are not showing up in the menus just yet, but nonetheless, the point still remains, which is when you're about to run a report, there are certain things that the system can determine itself, because those things are functions of the things you're going to run. So for example, a report will have a book or a number of books or a number of portfolios, to be more precise, associated with it. And then those portfolios will then pull in the instruments, and the instruments will then pull in things like market data and so on. So you'd start to slowly build up all these XML and TXT files by pulling in the instruments. But not everything is a function of the instruments. So for instance, if you open up your RE file, you'll see there's certain things here need to be stored somewhere. For instance, these parameters here should be a property of the report definition, or at least there should be something that the report definition associates with, because you don't necessarily want all of this stuff to be inside of the report definition, but it does need to be associated with the report definition. And so in an entity you will create the report definition, and the report definition will also tell the risk engine its configuration, again via some form of association. So what risk engines are we running, what parameters those risk engines have, and so on. Now this is a very, very simple pricing engine configuration. If you were to use something slightly more realistic, for instance, I suspect XVA risk will be sufficiently complex. You will see there's a lot more to it, and this is effectively a map that tells you per instrument the configuration of the model for that instrument. And so the system will, when the report triggers, execute the workflow for the report execution. So the first thing that happens is the scheduler receives the job, and if you look at the job definitions, well, we haven't scheduled anything yet, but were I to, for instance, do what we did on one of the previous videos, I can choose something like as frequent enough. I think headline position is the most frequent thing we got here. And if I just schedule this, so this was scheduled, I can see it's going to run soon, in about 8 minutes. Now this will, soon enough, is going to trigger, that again, this is lack of eventing, is really annoying. One of the things we need to look into very soon, but I suspect, okay, so some events are coming in, is good. You can see the events related to the scheduler are coming in, but not all are coming through. So as I was saying, once that job triggers, you can see the job here. It will run in a few minutes' time. It will trigger the workflow. The workflow will then execute. You'll see it here in the execution list. That workflow will be the workflow of generating a report instance. And the report instance then has multiple steps. This is not all implemented already, but what we'll do is, as part of the report instance, we create the report instance in first place. So in reporting, it will be an entry here of that report as it executes. It will obtain all the input data, it will generate a package, it will generate a batch. So all the things that we done manually will be done by calling the APIs. So I believe we were in the compute. So as we've seen here, we manually just generated this. We created a batch, we created a work unit, and then the work unit executed, the results were produced, and then we manually downloaded the output. And then obviously what should happen is the system downloads the output, it then post-processes the output, stores all the results somewhere, and then hopefully you would be able to see somewhere around here, you will be able to see those results. So the reason why, well, not the reason why, but last sprint we started working on the workflow, the notion of a workflow. It was much more complicated than expected. It's pretty much everything has been since we started this project. So we didn't really get as far as using a workflow to generate all of the steps that are needed to generate a report. And of course, as you've seen, we are still struggling with importing ORE trades, so presumably exporting is also going to be an issue. So we kind of, there's several things on the go at the same time. This is a property of working with multiple clouds. It's best to have several distinct tasks that don't overlap, and there's not a lot of conflicts between the files you're changing. So you end up with lots of things in parallel at different levels of execution. And that's a good thing and it's a bad thing, because you end up with a lot of features that are being added to the system, and you test partially those features, but it's not easy to make a complete picture of what's going on. So my mind is not quite made up yet as to whether you should have less tasks in the go and try to complete them, or whether it's better to have more tasks in the go, make the most of the tokens you got on the window, and then at the end have some kind of integration work, which is what we got now. We have lots of bits, but those bits need to be integrated, and they're not actually doing anything sensible end to end yet. But I think that's more or less where we are. I think, well, what we'll do in the next video maybe is to do an overview more in terms of the services and what they do. This has been more of a sort of UI focused sort of video. I think we probably need to start looking more under the covers and try to understand what's under the covers really. Actually, one more thing I'd like to do. I mean, these videos are a little bit jumbled up, but I just remember things as I go along. We are using the tenant admin, but of course, in the real world, because I tend to recreate databases quite a lot. But in the real world, you would create an account. I didn't do this last time, but I'm just going to quickly create an account here. This is the email. It could be anything you want, doesn't really matter. And the passwords, I'll just use my scripted passwords. So when you create a new account, you can give it some permissions. So for example, in this case, let's give it trading permission. And you can also associate parties with it. So for example, in this particular case, let's say we create an account for just this party. In fact, to be honest, let's just give it 2 parties really. Because if you give it 2 parties, you will see. Right, there we go. So if I just save this, and then I reload. So as you can see, the eventing worked there. So what I'll do is I'm just going to create another, not a user, another client. We had, let's create blue here. So in blue, we will log in as a regular user. I think since we've already seen how the super users work, it's probably worthwhile. So we also, actually we called it new user 1. Okay, I'll just create a new user 1 instead of a new user 3. The reason why is because I've already created all the credentials for these users, so this makes my life slightly easier. So as you can see here, so as we said before, I'm just going to give it trading. Assign a couple of parties. We definitely want to make sure we assign the routes. It is a bit difficult to navigate the, I mean, of course, this is probably a bad example that we have so many parties, but nonetheless. So that gets created, as you can see here, it evented correctly. We have the new user. So we go back to blue here, and then if I just choose new user 1 at Barclays. Right, as you can see, what I wanted to demonstrate is a regular user will have, in this case we have 2 parties, so you have to choose. If you had just 1 party, it will go automatically. And you can also see, because I'm not an admin, I'm not able to log into the system party. So if I just select that, now I will be able to see only the operational aspects of the system rather than the low-level aspects. Actually, what I really wanted was the Portfolio Explorer. The Org Explorer enables you to see the organization of the structure itself. The Portfolio Explorer joins the business units and so on to the portfolios, so it's a bit more useful. So as you can see here, this user can see the trades, just the trades. It's actually slightly faster, interestingly enough, than the tenant. Sorry, the tenant admin. I'm not too sure why. But that's what I wanted to show. Okay, so I think we probably have enough now for a video, so I think I'm just gonna call it, and then next video probably will, well, actually, maybe I'll stop the videos for now and then just focus on working on the sprint, and then at the end of the sprint, once we've finished solving, oh well, depending on how far we get in the sprint, but once we've done enough to possibly address the issues, we will then show the progress with the instruments and whatever other changes we've done to workflows and so on. So that'll be it for now. Thanks for watching.